So today's video is about solving exponential equations. So sometimes the letter that you're solving for is in the exponent spot. So some examples of this would be when 4 equals 2 to the x power, or 81 equals 3 to the x power, or 4x equals 64. Our x that we're trying to solve for is in the exponent spot, so there's a few steps that you need to do to get the x by itself. There's exactly 4 steps to solving equations with variables in the exponent spot. Number 1, you want to rewrite the bases of both sides as powers of a common base. So for example, when you have 4 to the equals x, when you have 4 equals 2 to the x power, you're going to rewrite the 4 as 2 squared, and you're going to leave 2 to the x power the same. The bases are now the same, but they both have a base of 2. Alright, when you've got 81 equals 3 to the x power, 81 is the same as 3 to the 4th power. So 3 to the 4th will equal 3 to the x. Step 1 is simply rewriting. Step 2 means simplify exponents. Sometimes when you rewrite the bases, you're going to have to simplify the exponents. So in this example, we've got 2 to the 4x power equals 8 to the x minus 1 power. I'm going to rewrite the 8 to being a base of 2. So I'm going to just replace the 8 with 2 to the 3rd power because 2 to the 3rd equals 8. So I didn't do anything other than just replace the 8, which means 2 to the 3rd power is being raised to the x minus 1 power. When you raise a power to a power, you multiply. When you raise a power to a power, you multiply. So I'm going to multiply the 3 in 2 cubed times x minus 1. To multiply like this, I have to distribute. So I'm going to take 3 times x is 3x, and 3 times negative 1 is just negative 3. The third step is to cancel the bases and set the exponents equal to each other. So from that previous example, we ended up with 2 to the 4x power equals 2 to the 3x minus 3. When the bases are exactly the same, they cancel out. So you can just cross out those 2's, and what you're left with are just the exponents. 4x is to equal 3x minus 3. The last step is something we've been doing now for a long time. You just solve the equation. So 4x equals 3x minus 3. Subtract the 3x from both sides. X is going to equal negative 3. You can check your answer by plugging it back into your calculator. And you end up with 2 to the negative 12 is the same as 8 to the negative 4th power. When you plug them into your calculator, you get the same decimal value. So a couple more examples. Alright, in this example we want to solve for x. I get 2 raised to the 2x power equals 1 over 16. Alright, so whenever I see a fraction right there, I know that the exponent is negative because it made that fraction 1 over 16. So I think about what power would take 2 to 16, and 2 to the 4th power would. Well, since the 16's in the denominator, I know it's raised to the negative 4. So I get 2 raised to the 2x power equals 2 raised to the negative 4. I need to simplify my exponents. Well, I don't need to do that in this problem. Cancel the bases, and I'm left with 2x equals negative 4. Then I need to just solve the equation. So when 2x equals negative 4, x must equal negative 2. Another example, 4 to the x minus 3 power equals 8. Well, the first step is get the common base. Well, since I can't raise 4 to a power to get 8, I'm going to set them both to 2 raised to a power. So I can replace the 4 with 2 squared, and I can replace the x with 2 cubed. Step 2 is simplify my exponents. On the left side of the equation, I see that I've got 2 raised to a power and then raised to a power again. So I have to multiply 2 times the x minus 3. And I get 2 raised to the 2x minus 6 equals 2 cubed. Step 3 is cancel the bases. I'm left with an equation. Step 4 is solve the equation. Add 6 to both sides, divide by 2, and my x equals 4.5.